Were you aware that toothpaste has a history that dates back almost 4,000 years? Doesn't it sound strange? Watching the movie will provide you with further information regarding the manufacturing process of toothpaste, even though toothpaste in those days was more complicated than it is today. Green leaf, verdigris, and frankincense were the three components utilized by the ancient Egyptians. Some of the earliest Chinese people made use of ground bones. The following components are included in every toothpaste: water, binders, abrasives, propellants, humectants, scents, sweeteners, fluoride, bleaching agents, and preservatives. Binders make toothpaste more viscous. To eliminate plaque and loosen particles stuck to the teeth, abrasive materials are used to scour the exterior of the teeth. The presence of abrasives also influences the opaqueness of the paste or gel. The consistency, cost, and flavor of the paste can all be influenced by the presence of abrasive components. Silica, calcium carbonate, and sodium bicarbonate are the three types of abrasives that are utilized the most frequently. The cleaning capabilities of each abrasive are also slightly different from one another, and the finished product may contain a blend of the two types of material. Surfactants lower the surface tension of the water, also called foaming agents. This results in the formation of bubbles. Alkali metals and organic alcohols or fatty acids are often the components that come together to form foam. Water is retained by humectants, which helps to maintain the moistness of the toothpaste paste. Moisturizers preserve the cohesiveness of the toothpaste's solid and liquid phases. Additionally, they can impart a coolness and sweetness to toothpaste, rendering it more pleasant to use in the mouth. Propylene glycol is another option for usage as a moisturizer, while sorbitol or glycerin are the humectants that are utilized in the majority of toothpastes. The flavor of toothpaste allows it to be more enjoyable to use. As a result of its refreshing flavor, mint is the flavor that is utilized the most frequently. This clean sensation is the product of the toothpaste industry's constant conditioning over many years. There may be a rationale behind mint being associated with a sense of freshness in the United States. In the mouth, the mint flavor contains oils that evaporate when exposed to the warm environment of the mouth, resulting in a sensation of coolness. Three varieties of toothpaste are the most commonly used: peppermint, wintergreen, and cinnamon. To impart a delectable flavor, toothpaste is formulated with sugars and flavorings. The most popular moisturizers contain humectants, which cause them to be approximately 60% sweeter than regular table sugar. To have a pleasant flavor in the toothpaste, artificial flavors are also required. Although ammonium glycyrrhizate and aspartame are sometimes found in toothpaste, saccharin is the sweetener that is used more frequently than any other. Following their arrival at the factory, the raw materials are subjected to both manual and mechanical weighing before manufacture. Because of this, the proportions of the ingredients are guaranteed to be accurate. Following that, these components are combined. In most cases, the initial step is to prepare a mixture of glycerin and water, and then all of the materials are combined in a mixing bucket. It is essential to carefully monitor the temperature and humidity of the batch to guarantee that the mixture is brought together correctly. The tanks that are typically utilized in the toothpaste sector are capable of mixing one batch, which is comparable to 10,000 canisters that are 4 ounces in capacity. To guarantee that the tube is clean before it is filled with toothpaste, it is cleaned by passing it through a fan and a vacuum. A blower is used to remove dust and other particles at this stage. Because the opposite end of the tube is open, the tube is closed so the filling machine can load the paste. After the components are mixed, the tubes are filled by the filling machine. An optical device rotates the tube to guarantee that it is aligned correctly. After that, a submersible pump delivers the liquid into the tube. When they are complete, the ends are then sealed. There is also a code that is imprinted on the tube, which indicates the location and time that it was generated. Now let's look at a comprehensive review of the operation that goes into toothpaste production. The current invention describes a method that allows for the quick and agglomerated addition of the abrasive calcium carbonate powder that is utilized in the production of dentifrice compositions simultaneously. A significant portion of the product is comprised of the powder. In comparison to the art powder addition technique that was previously used, this method brings about a tremendous simplification. Following the addition of water and toothpaste humectant carrier materials in the mixing tank, the abrasive calcium carbonate powder is injected as a high-density slurry that contains between 50 and 80% solids by weight straight into the liquid carrier, and then the mixture is mixed. Intimate mixing is used to homogenize the ingredients until they are uniformly distributed. Because they do not lessen the likelihood of tooth decay or gum disease, abrasives are technically considered inactive ingredients, even though they play an active role in toothpaste preparations. Nevertheless, if you have them, your toothpaste will have little effect. The removal of food residue and stains from teeth is accomplished using abrasives, which are materials. Today's abrasives typically comprise calcium carbonate, dehydrated silica gel, and hydrated aluminum oxide. They are also more pliable than their predecessors. In today's toothpaste, the abrasives are designed to scour the surface of the teeth without scraping or otherwise destroying the enamel. This is the way that current toothpaste works. Using a toothbrush and a few swipes of toothpaste should be plenty to bring out the shine in your teeth right now. It is possible to make gel toothpaste by utilizing a Silverson high shear mixer. However, due to the high viscosity and abrasive qualities of white toothpaste, high-speed rotor or stator mixing is not appropriate for some aspects of the process, but it can bring considerable benefits at other phases of production. These include the following. Regarding toothpaste production, aeration is one of the most significant challenges. Air is present in every powder, and detergents have the potential to make the situation much more severe. To mitigate this effect, mixing is typically carried out in a vacuum. This rheology modifier tends to create lumps, which are exceedingly difficult to break apart even with vigorous stirring. Pre-mixing with other liquid or powder materials increases the time and money required for processing. Several developments in toothpaste have occurred since the fluoride discovery, and these developments have entailed the addition of substances that provide unique capabilities to toothpaste and the packaging of toothpaste. The term tartar control became a popular topic of discussion in the toothpaste industry throughout the 1980s. Tartar control toothpaste claims that it can prevent tartar accumulation around the teeth. Additionally, in the 1990s, baking soda and other components were included to remove tartar and enhance the health of the gums. In the 1980s, pump and stand-up tubes for toothpaste were produced and advertised as a cleaner alternative to collapsible tubes. These tubes were designed to be used for toothpaste. A nationwide launch of the Colgate pump took place in the year 1984. Even though collapsible tubes were still commercially available, stand-up tubes became the standard in the industry during the 1990s. The liquid carrier that is used in the toothpaste product that is manufactured by the invention is typically a mixture of humectant and water. It is generally included in the final paste product in the range of approximately 10 to 85% by weight, with 30 to 70% being the ideal amount for toothpaste. Glycerin, sorbitol, propylene glycol, polyethylene glycol, mannitol, polypropylene glycol, and mixes of these substances are examples of humectants currently utilized in toothpaste formulation. These humectants are well known in the industry. For the most part, the stable aqueous suspension of calcium carbonate that is used in the process of the present invention typically contains between 50 and 80% of calcium carbonate by weight. There are a lot of industrial processes that are comparable to the process of making toothpaste. Chemicals are transported in sacks and stored in huge containers after being measured. After all the components have been mixed, they are brought to a boil in a large aluminum kettle to forestall unintended chemical reactions. I find that to be fascinating. To guarantee that toothpaste is of sufficient quality, a specialized testing department spends a significant amount of time each day testing all the different flavors and batches. After receiving approval, the tubes are then filled by machinery that is a state-of-the-art. So if this is the end of today's video, do you like it? Kindly give your valuable response in our comment section below, and remember to subscribe to our YouTube channel for more exciting and informative videos.